Hey, Campbell.
Hey,
How are you?
good.
Did you have a specific question or did you just come to hang out?
Come to hang out.
Oh, okay. Well, thanks for showing up. I was actually playing around with there's a way for me to use the stylus that they gave me, and I was trying to capture a piece of the review sheet that we did yesterday and move struggling with it. Did you get done with the review sheet?
Sorry, my earbuds fell out.
Oh, that's okay. Did you get done with the review sheet?
Like the worksheet?
Yes, ma'am.
I did.
Did you? I was going over the test to make sure. You know how I said to you guys that uh, that the review was actually going to be harder than the test. I wanted to make sure that I wasn't fibbing about that. And so I was actually going over the test and doing a comparison. And I do really feel like, the that car question with the graph, no
Yeah,
question number 11 through 16.
that was hard.
Okay, there are two of those on there. Um, let's see. And it was the rates of change. You know how we figured those out? Like, uh, let me go ahead and turn this on. Can you see my review worksheet?
Yeah,
Okay, good. Did can you still see it?
yeah,
Okay, good. I was trying to blow it up a little bit. But you know how we from here to here we said that was 60
mm-hmm.
over 2, and which reduces to 30.
Yeah,
Okay, it's going to be about that easy. There's only 2 points on the one on the test, but you do have to reduce it. So like this one right here, remember how this one you were like, how did you get negative? And I was like, okay, it's declining. So it was a negative 120 over 4 because it was the difference between 4 and 8. And so then that reduced to a negative 30.
yeah,
Okay. So it's going to be like that. And so this one, we said the car was traveling to the left because it was a negative. And so you'll have to know that. If it's negative, you travel to the left. And if it's positive, you're traveling to the right. That's the key things that you need to know for the test. Does that make sense?
yes, it does.
Okay. Was for you, was that about the hardest thing on that review sheet, or was there something else that was hard to
Mhm.
you?
Yeah, that was probably it.
Okay. All right. Well, I since you asked about it, and when I went back and double checked the test and everything, I did want to make sure. Um, a couple of other notes. Since I have you, we might as well cover them. A couple of other notes, making sure that you know how to put an equation into mx plus b form, y equals mx plus b format. Are you good on that?
Yeah,
Okay, good. And then the one other question, are you real clear on like how to graph an x-intercept and a y-intercept?
mm-hmm.
Okay, great. Those were the only things, like I felt like there were similar questions on the review, but I just wanted to make sure not only can you find an x and y intercept, but you also know how to graph it. That's important too.
Yeah,
So since you showed up, I might as well make sure that I cover everything. I don't, no surprises for those sweet people that show up.
I'm trying to convince my friend to show up too so she can get this.
Oh, okay. Who? Which one? You have lots of
Jordan,
friends? Oh, Jordan. Yeah, she needs to come.
I'm emailing her right now.
Tell her she doesn't have to show her face. None of us do. We know it's our off day, right, Campbell?
Yeah,
Most of the time, Evan shows up eventually. He might be on now. He's just shy and doesn't speak. He just shows up.
No, he's not here.
Okay.
I can't.
Why not? You can't be down here. You can't keep talking.
I'm trying to pull up the test too on my other computer.
I'll put it on mute for now.
Something I see on the test, which we had in homework questions, but I don't know if I had it on the review. Let me look through. Okay. Something that's on the test that wasn't on this, but we did have it in homework, was telling whether an ordered pair is a solution of the equation. Do you know how to do those?
I do.
Okay.
And Jordan joined.
Oh, okay.
Hi.
Hey, Jordan. How are you?
Good.
Good. Well, I'm going to do one of those for you guys just to make sure that you do know how. So, this is a type of question that's on the test that was not on the review. So, the instructions are to tell whether the ordered pair is a solution of the equation. So what you would do is plug in the x.
I think I know the answer already.
You do? You're so smart.
Is it no? I don't think it is.
Okay.
Wait, no, wait. Yes, it is.
It is?
Yes.
Okay.
My brain is messed up from DC.
I understand. So I'm going to subtract 2 from both sides and get -3. So I plugged in a +1 in for x, and I ended up with -3 for y. So it is a solution. So the answer to that question would be yes. But that's how you solve that. And there's 3 of them on the test tomorrow that are like that.
I did it. I plugged in both x and y and solved, and if it equaled the actual answer, then I would put yes or no.
Oh, that's perfect. Either way works. Perfect. That's the beauty of math. That's part of, to me, that's the art part of math. Everybody kind of views a problem a little differently. And once you learn all these different ways to solve them, you can, because that works fine. Not a problem. Good idea. Let's see. Let's go back through. I'm just going to put the review back up there and make sure. Jordan, you stop me anywhere that you have a question, okay?
Okay.
Here is the review that we did in class, and I have the test pulled up here. There are definitely 4 questions just like those that start the review. There's 4 questions just like that on the test. The only difference is on the test, you have to tell what coordinates they are. They're already plotted for you. So you have to tell what the ordered pair is. So like this would be plotted for you, and you would have to actually write down the ordered pair and what quadrant it is in. Does that make sense?
Yeah.
So, so plotting this one, -1 and then up 3, my answer would look like -1, 3, beautiful 3, Miss Sparks. And then I would put Q or quadrant 2, however you all do it, whether you write the whole word or just write Q. So that's how you would do that. And if it fell on one of the axes, like I believe one of them did, number 2, B, fell on the X axis, you would just write X axes.
Oh, okay. I was confused about that yesterday.
Yeah. Okay. You would just write x-axes, and one of them on there tomorrow does, instead of falling within a quadrant, it does actually fall on one of the axes. So that will be just like it. Like I say, I tried very, very hard to make the review much like the test so that nothing, the next ones where you have to graph the equation, there's some of those on there. There's also ones where you have to graph, see where it says down here, find the X and Y intercepts of the graph below of these, and where you had to find the X and Y intercepts. You actually have to graph the X and Y intercept and then connect them on a graph to make a line. Are both of you all comfortable with that? Or would you like me to show you? Jordan, how about you? Are you okay with that, or would you like me to show?
Yeah, I'm good.
Okay. All right. Just stop me anywhere. And then Jordan, before you joined, I was talking to Campbell about this problem, the problems down here on exercise 11, because I think Jordan and you guys said that this seemed to be the hardest part.
Yeah, it's kind of difficult.
Okay. There are two problems much like that, but only two, it's not six like it was on the review. But you'll have to find like the rate of change. Like, let's just go to this big rate of change here. That goes from 120 to 0. So it's negative 120. And it happened over 4 hours. So that would be negative 120 over 4, which reduces to negative 30. So the rate of change is negative 30. And when it's a negative velocity, the motion is to the left. So you would have to know, you would have to be able to read the graph for the miles over the number of hours, and that is your rate of change. And then you would have to tell me if it's negative that the motion was to the left. Does that make sense?
Yeah.
Jordan, did you get that, or do you want me to go back over it? Okay.
I get it.
So if it's a positive rate of change, then the travel would be to the right. So let's see. Stop me if you have any types of questions.
Okay.
I have a random question, though, relating kind of to the math problem.
Okay.
How can you travel negative amount of space?
Oh, that's a really, really good question. Yeah.
You put the car in reverse, Campbell.
It could be that. There's a lot of different things. That's where this word right here, and it's interesting because this is, both of you all are smart enough that you might actually take physics, but actually you'll study a little bit of this in physical science. But velocity is, okay, speed, the difference between speed and velocity is one can be negative. Okay, speed is always positive because you're going in you're moving at a rate of speed, and it's typically positive. But velocity is where negativity comes in because it's directional, because it's always taken a direction into consideration. So a lot of times velocity, most of the time, is not a left or right thing. It happened to be for this problem, but most of the time velocity is up or down. So like, say for instance, when someone is jumping out of an airplane, it would be measured in the speed would be measured in velocity, because obviously they're going down, and so that the velocity is a negative motion and the speed is a positive. So velocity is when you're taking a direction and a speed in consideration. And that's why they use the word velocity here, because right is considered positive and left is considered negative. But the speed itself, because it's going this way, the distance and the speed is the distance. That's always positive, and that's why it's measured on that y-axis. But velocity is directional. But great question. I hope that made sense. But that's where science comes into consideration. And so I know you're like, Miss Sparks, why did we have to bring science into math? But that's where basically that's where all that comes from. And that's why they're trying to have us use more of these charts, like I told y'all yesterday in class. A lot of this type of stuff on the ACT is on the ACT. It's being able to read graphs and charts and pie charts and data and things like that from a scientific thing and actually applying your math skills there. That's about 50 to 60% of the science part of the ACT test. So I'm trying to give you guys good experience there. Even though, so does that help explain that?
Yeah, and I think Evan joined.
Oh, he did? Oh, good. Thank you for letting me know because I can't ever see who's on there. Hey, Evan. Yeah, somebody does know your name. I can't tell when I'm on the other page. So thanks for letting me know.
Yeah. I'll let you know if he says something.
Okay, thank you. All right. So did y'all get the answer to what does the x-intercept represent? We talked about that in class, didn't we?
Kind of.
Okay, the x-intercept actually represents the beginning and the end of the trip, the beginning of time and then the end of how long they traveled.
Got it.
Okay, so it represents time, like in the beginning and the end of this travel time, I guess would be the best way to say it. Let's see. Move along. Identify the slope and the y-intercept in these. And I didn't have two answers, like two answer spots here for it, but the coefficient on the x is the slope, and it's represented by the m, and it's 8. And the y-intercept is this part right here. And you have to take the sign in front of the number into consideration about that. And it's represented by a b, and it's -3. And this one is not in y equals mx plus b format. 2x. What was it? 2x plus 9y equals 9. So this one, in order to identify the slope and the y-intercept, I would have to put it into y equals mx plus b format. So I'm going to begin by subtracting 2x from both sides.
Oh, I just got my worksheet out, and I forgot. There was a couple questions I had.
Okay. I'll finish this one, and then we'll go to that next question. Then I'm dividing both sides by 9. Good. I'm glad you have a specific question. I love that. So what would my slope be in this one?
-2/9.
Good job.
And what number is this again?
That's on the back side of the sheet. Let's look at it. It's this one right here, number 18.
Got it.
Negative 2 over 9. And then the y-intercept, which is represented by a b, is a positive 1. This part right there. So that's the y-intercept. Okay, what was your specific question?
I had a question on 20, 21, and 22.
Okay. Cool.
I mean, like, I know how to do it, but my brain got confused.
Yeah, I'm going to be honest with you. I feel like slope is one of those things where it can really be a tricky thing. And I never want to get my, the things that make, hold on just one second. I had a pencil at the table and then it went away and I don't know where he went. Is one of those things, and like I say, I never like to get my little confusing things. I never like to pass those on to my students, but sometimes I wonder if because the x goes first in the coordinate pair and the y kind of goes first, if you will, in the slope format. Does that make sense? Because, when you're
Campbell, what did you do?
I don't know.
You muted her.
I didn't mean to. I don't know how to undo it. It's not letting me.
Hold on.
how's that?
That's better.
That's better.
Okay. All right.
I accidentally muted you.
Oh,
I didn't know you could do that.
I didn't either.
I didn't know you could do that either. That's okay. That's okay. I heard. I could hear y'all. So, but what I was saying is that I don't know where did y'all hear me? Last hear me?
I forgot.
Okay. Well, we were talking about slope, and like I think I didn't want to actually get any, didn't want to add confusion or anything, but what I feel like is why it can be confusing is you've got this. So the y kind of seems to go first here because it's on top. And in your ordered pairs, like in this one, I've got -4, -3, right? That's 1.
Yeah.
And -1 and 1, correct? That's what is that, number 20?
Yes.
Yes, okay. I wanted to make sure they got them right. So here your x goes first, and over here it's kind of like you're dealing with your y's first. And then I typically will write mine up and down. That just makes more sense to me. So, and then I'm going to make this my y2, my x and y2, sub 2, and this is my y, x and y1. So I've got -3 minus 1, that's this part, on top, okay? And then I've got -4 minus a -1 on the bottom. That's this on the bottom.
Got it.
3 minus 1 is -4. And -4 minus the -1 technically becomes -4 plus 1, right? So that gives me a -3. So I've got a negative over a negative, which is really positive. So my answer is 4/3 for the slope. Is that what you got?
Yeah.
Does that feel better?
A little bit.
Okay, so do you want me to do the rest of them?
Please.
Oh, not a problem. I love when you guys have questions in math lab. Makes my day. So I'm going to, I probably didn't really need to erase the formula, but I did. I'll go ahead and rewrite my formula. Y sub 2 minus Y sub 1. And that's just to make sure the little sub numbers are just to make sure. Oops. I messed that up.
I don't think you can do the same Y twice.
Yes, I know. I messed that all up. This is just to make sure that you start with the same coordinate pair every time. See how this coordinate pair is, in alignment vertically, and this ordered pair is in alignment vertically. One of the biggest things that you need to make sure of and always be consistent in is that this ordered pair is on top of each other. Does that make sense? So, let me give the example. We were given this ordered pair, -1, -3, and 4, -3. All right. So,
-3s.
I'm sorry. Yeah, mega.
There's a lot of -3s.
Yes, there are. So this ordered pair here is going to be my x2, y2. And this ordered pair is going to be my x1, y1. But it doesn't make any difference which way you do it. You just have to make sure you remain consistent throughout the problem. Does that make sense?
Yes.
And I'm going to erase that because that looks like it's going to be the line. Okay, so now what I'm going to do is do -3 minus a -3, because that's this right here. So that's my y2 minus my y1. And then -1 minus 4, which is this. That's my x2 minus my x1. So -3 minus a -3, that turns into a plus. So I've got -3 plus 3, so that's going to be 0. And this down here is going to be -5. So that tells me the slope is 0. So that tells me I even know what the equation of this line is, because it's going to be a horizontal line at y equals -3.
Huh.
Because when it's a 0 slope, I know it's a horizontal line.
Right. So when we're answering that on the test, do we have to put y equals -3?
Absolutely. No, you do not. I just was showing you that you could know that. Like a lot of times, if your y's, see how your y's were the same here?
Uh-huh. Yeah.
You see that and you go, oh, that's a whole lot of -3s going on. You could have automatically said, you know what, both of the y's are the same, so this is going to end up being a horizontal line.
So still on the test, we would still put 0 over -5?
Yes, ma'am. Or
Okay.
m equals 0, either way. I would take either answer. You could write this, or you could write this. I would take either one.
Got it.
Okay. I just was letting you know that when I know that the slope is 0, every single time I absolutely know it's going to be a horizontal line.
Got it.
I'm just trying to make sure that you know that, because you'll need to know that for Algebra 1, you'll need to know that for geometry, and you'll need to know that for Algebra 2. Yay.
It's so weird why they do geometry in between Algebra 1 and 2.
Yeah. I kind of get where you're coming from, but a lot of the things that you're learning this year, you actually apply in geometry. So you'll use slope next year. You know, some of those problems, which Evan had them on the review sheet, but they were a lot harder than the ones that we had on the worksheets. But you know, the ones where you were given the slope and you were given 3 of the 2 coordinates of the ordered pairs, and you had to figure out what the missing coordinate was. Do you remember those by chance? It was well before Washington, so you might not.
No, I don't, honestly.
Unfortunately, well, or that is exactly what you'll use the slope for in geometry.
Huh.
Like
Jordan, do you remember that?
Let me see if I can find one. I don't see if I can find one from the worksheet. It's not going to be on the test, so I don't really want to
Oh, good.
boggle your mind with it now. Okay, sorry. I was trying to look for one of those, and then I thought, I don't want to clog your little sweet little brains with something that won't be on there. All right, do you want me to do the last? You want me to do the last slope problem?
Sure.
Okay, let me jot it down because I can't remember those points from one screen to the next. Oh, Miss Sparks, your poor brain. Okay, so once again, the formula. Maybe I'll get it right this time. Yay.
Yay.
So here's the ordered pairs. And so now what I'm going to do is, this is going to be my Y. Oops. My X2, Y2. And this is going to be my X1, Y1.
Oh, Natty Grace came in.
Hey, Natty Grace. So I've got 3 minus.
She said, hey.
Hey. 3 minus a minus 3, and then negative 2 minus 1. So that's going to be 6, because 3 minus 3 turns into 3 plus 3. And then negative 2 minus 1 is a negative 3. So this reduces to m equals negative 3. How did you do on those?
I did pretty good. There's one more question I have.
Okay.
Number 19, because when you did number 18, I missed part of it, and so I want to make sure I understand.
Okay. All right. So 19, 3x minus 4y equals negative 16. I'm writing it down.
Evan said he has to leave.
Oh.
And he'll see you later.
Okay, Evan. Take care.
He left.
Okay. Is Natty Gray still with us?
Yes.
Okay. All right. Negative 3x minus 4y equals negative 16. So I'm going to get it in y equals mx plus b format. That's what I'm going for. So I'm going to add 3x to both sides because I'm trying to get everything, you know, from away from the y slowly but surely, which that leaves me with negative 4y equals 3x minus 16. And then I've got to divide both sides by 4. by -4, actually. So that leaves me a y equals -3/4. And it doesn't matter where you put your negative when it's a fraction like this. You can put it up here or you can put it down here. Just one of them has to be negative. But this is -16 divided by a -4. So that's going to give me a +4. So my slope is -3/4. Nice 4, Miss Sparks. And then my y-intercept is 4 because this is the y-intercept and this is the slope, the coefficient of the x.
Got it.
So that's how you do those. But with regard to slope, right here, it doesn't matter which one, because sometimes, like when you're graphing, that's nice. That's all clogged up. Beautiful. When you're graphing, you can go in one negative direction and one positive direction when it's a negative. And most of the time when you're graphing, obviously that's what you're going to do. So on this particular one, my y-intercept is 4. So 1, 2, 3, 4. So I would graph right here.
Is that your dog in the background?
Not mine.
Dog. He barks at everything.
And so we'll go down. My dog normally does too. I'm kind of surprised he didn't bark back at your dog. 1, 2, 3. I would go down 3. And since I went one direction negative, I want to go one direction positive. So 1, 2, 3, 4. So it would be there. And vice versa. It's not very good at making a dot. Okay. Here, if I'm going to go up 3, 1, 2, 3, I would go left 4. So my dot's going to be over there somewhere. So my line would look something like that for this particular equation.
Oh, cool.
Okay. So that's how you use the y-intercept and the slope. And that's why I say it doesn't really matter where you put the negative. As if the slope is negative, it can be on the numerator side or the denominator side. Just one of them has to be negative. Okay, were there other questions?
I think I'm good.
I had a question about number 25. I don't know why, but I just can't figure it out.
Okay. Okay, so compare the graph to the graph of f of x equals x. All right, on this, right here, this is kind of what we're calling a parent graph. And it runs through the origin like that. Okay? Because what it's saying, remember this thing right here is just a fancy y. So this really is y equals x. Just a fancier way to say it. And because this is called function notation. So this also is linear in this function notation. And when it says compare, what it means is what are the slopes for both of them? Okay, and the slopes are the coefficient on the x coordinate or the x variable. So what is the understood coordinate there?
What is the what?
Understood coordinate in front of this x and in front of this x.
1.
1. So it's an understood 1. So the slope for both of them is 1. So when you're comparing, you would be like both the slopes are equal. But the y-intercept for this one, which is these two are the same thing, the y-intercept for the one that they're asking you to compare it, or let me not write that. I'm going to go back to this. The y-intercept for the given is 0. But the y-intercept here is -5. So it's going to be right there. Okay?
Okay.
But the slopes are the same. So I would go over 1, up 1, down 1, over 1. So the slopes are the same. So you would say slopes because, well, are the same. Y-intercept are different. And because the slopes are the same, what are the lines? What do we call lines that have the same slope?
Parallel?
Parallel.
We would say the lines are parallel. So that's how you compare the graphs. You graph both of them. And then you would write slopes are the same, so the lines are parallel, the y-intercepts are different. One is 0, one is -5. Does that make sense?
Yes.
Okay. All right, let's do number 26 just to make sure, because on this one, the slopes are definitely not the same. The slopes are different on these two.
Miss Sparks, I'll be right back. I gotta grab my charger. My computer's about to die.
Okay.
I just gotta plug mine in. Mine is about to die too.
Okay. All right. Well, I'll keep erasing while y'all do that. Oh, my other computer's about to die, so I better plug it in. That's where I'm pulling some of my problems from.
I'm back again.
Me too.
Okay. All right, we'll do this number 26, and then I'm going to go back over the test one more time and make sure that there isn't anything else that isn't answered. Okay. On this one, the slopes are different. So here is my parent graph, because it's just the one, it's a straight line with a positive slope and it's running through the origin. Okay. So that's this graph right here. And that's how you graph it. Okay. But the slope is different on this one. Our slope of the parent graph, the slope is what? What did we agree that it was?
1/2.
1. Well, on the parent graph, this one.
Oh, it's 1.
1. Okay. And you're right. Somebody said, what is the slope for the graph for number 26?
-1/2.
-1/2. So the slopes are different. So you would write that. Slopes are different. So the lines are not parallel, are they?
No.
So there's probably a good chance they might intersect. But one thing that is the same, what is the same on these two? If you had to guess.
They both have X.
Yes, and there's one other thing. There's something missing. If these were in y equals mx plus b format, what's missing on both of them?
There's not a y-intercept.
There's not a y-intercept, or there's not one given, because basically it's saying it's +0. And so mathematicians, don't write that. So both of them go through the origin. So both of them are going to start there because the y-intercept is 0. And I know on a y-intercept, in order to find it, the x is 0. So if the y-intercept is 0, then the x-intercept is 0.
Okay.
All right, so both of them are going to go through the origin, but the slope is -1/2, which means I have to travel in one negative direction and one positive direction when I'm doing rise over run. So if I go up 1, then I have to go left 2. So I would go from the origin, I'd go up 1, left 2. Let me get a little bit. But if I go down 1, that's a negative direction, so I have to go right 2 into a positive direction. And so then, so left 1, up 2. Oops. Did that wrong. Up 1, left 2.
Will we be able to have a ruler during the test tomorrow?
Sure.
Cool. Because
Down.
having no straight lines bothers me.
Yes, I know my lines are making you happy.
Uh-huh.
They're beautiful, aren't they?
Awesome.
Okay, so this second graph is the graph. So when you're comparing them, you're basically you're drawing them on there, because obviously the drawing of them is a comparison in itself. But you're also letting me know the slopes are different, and then but you could tell me that the y-intercepts are the same on these.
Got it.
Okay, so basically you're just giving me a little bit of information based on the graph and a little bit of information based on the equation itself.
Okay.
Okay, so that's what it means to compare. I'm trying to, let me go back. Like I say, I told Jordan and Campbell earlier that I was trying to look at the test too, to make sure that I covered any, so there would be no surprises for you guys that showed up.
Mm-hmm.
And I did, before you joined, I did tell them that there are 3 questions on there that weren't on the review, 3 types of questions, but you all had them in homework. And they were like confirming that an ordered pair was a solution. They were also on the quiz, confirming that an ordered pair was a solution to an equation.
Mm-hmm.
And I gave them an example, and I'm just going to give that example to you, for showing up. So say, for instance, 2x plus y equals -1. And then the ordered pair that they want for you to tell whether it's a solution. Campbell actually worked hers this way, which is definitely a way to do it. Just plug it in like that. And then.
That's right. Woo.
Yeah. So you would say, yes, it's a solution. And then the review here, right here, where it said find the x and y intercepts of the graph, you have to be able to graph them on the test tomorrow. And then draw a connecting line between the 2 of them. But the graphs are given. But that's something that you have to be able to do. There are these car questions, but they're not quite as hard. It's just basically giving the rate of time. How did you do on those? Were you okay with those?
I was okay with those.
Okay. You definitely have to be able to put an equation in y equals mx plus b format. And, oops. You have to be able to do these tables. Were you okay with these?
Can I check my answers on 24?
Absolutely.
I got 0 and -7.
Hang on.
0 is
I got 0 and -7 too.
Okay.
that 0 is correct and -7 is correct.
Sweet.
And you feel good about this one?
Yes, ma'am.
Okay, good.
What was-
what are the answers to 23?
The answers to 23 are 5. And then let's see.
Negative.
This is 6, and then this would be.
I got -4 for that.
Yeah, that's what I got.
It is correct.
Doing the tables are really easy because you're just like plugging in numbers.
Right. So, but
Miss Sparks,
you
what
might
was
see that one again? What?
What was today's assignment? Like the problems we were supposed to do today?
You were supposed to finish the worksheet, and then if you felt like you needed additional practice, this isn't required, but there's a chapter summary at the back of the book, like a chapter, like review problems. If any of these were difficult for you, you were supposed to work on those.
Got it. I accidentally thought they were like required for homework. Started doing them.
Well, I would only, in all on, oops, wrong book.
That's algebra 2.
Yeah,
Not
Yeah,
there.
wrong.
we're not there yet.
I will be next year. Woo.
Yes. Well, yes. Let's see.
It's still on algebra 2.
So sorry.
That's weird.
There's algebra 1.
There we go.
There we go.
So, here. And I put that down there because and I wrote it all the way out because I didn't want anyone to do 3.6. I mean, you need to know how to plot those lines right there. I think you need to know how to graph the equation and make those tables.
I can do that.
You need to know how to graph using intercepts.
Mm-hmm.
This in particular, I might add, this is going to be really important to be able to do that. You see right here, where on this example in 3.3, how they graphed the two intercepts and then drew a line through them to make a line.
Mm-hmm.
That's really, really important that you know how to do that. So 11, 12, and 13. Very important.
Okay.
What about 14?
Oops. There won't be anything like 14 on there.
Okay, good.
Okay. Let me see. Where are we? You have to be able to find the slope, which we did. We did some problems like that. You have to be able to graph using the slope intercept. So you have to be able to put it in slope intercept form.
Okay. Tessa joined.
Hey, Tessa.
Hi,
How are you?
I'm good. How are you?
Good. I was trying. I'm just going through the oh, you don't have to do anything on 3.6, and you have to be able to do
3.7.
yeah, the comparing. No, evaluate the function at a given value.
I can do that. That's good.
Like the 29 and 30 are the most important ones in that part.
Where you
And
have to find out what.
actually, on yesterday's classwork, where you had to evaluate the function at a given value, and then the next few, you had to do it in reverse, and you had to figure out what the X value would be if you got this answer. Remember how you had to do, I think it was numbers 3 through like 11 where you had to plug the value in to get an answer, and then like 15 through 23, you had to work backwards and go the other way.
Yeah.
You have to do that for the test.
Okay.
Okay.
Mm-hmm.
How do you do 23 on the worksheet? Like 23 and 24.
Okay. On those, let me see. You have to plug in the value to get the right answer. So like for this one, it's giving you the X. So it would be 6 plus a -1, which would give you a 5. Okay? Does that make sense? Tessa? Is she still there?
Okay.
Are you there?
Yeah.
Okay, so what you're doing is this is the X right there. So you would have, so you would just plug in that value for that. So on this one, you would plug in a 0 for the X. So it would be 6 plus 0 equals 6.
Okay.
And now this one, you would plug 2 in for the answer because this is f of x. So you're going to plug 2 in as the answer and do 6 plus x. So then you would get -4 equals x.
Okay.
So very much like some of those problems we were doing yesterday in class, you've got to know where to work forward or backward. Oh, I should have left the answers. Sorry.
It's fine.
And so I'll do the other ones too. So for this one, on the first two, you're given the x value. So you'll just plug in that value where there's an x to get an answer. So f of x equals -7/2 times 0, which anything times 0 is 0. So this is going to be 0, right? And then on this one, oh, I shouldn't have erased the f of x. It's going to be the same for the next one. F of x equals -7/2 times 2, because I'm plugging in the 2 where the x is, and I'll write it as a fraction because it'll make multiplying it easier because I can simplify before I multiply. So that leaves me a -7/1, which is -7. So that's that one.
Okay.
So it's just basically those same problems that we did yesterday in class, except in table format.
Okay. How about 25?
25. This is like those at the latter part of the homework yesterday where you're comparing the graphs, and you'll do one by actually graphing the equation. So this is what, remember I talked about this a little bit in class yesterday as the parent graph, and it goes through the origin.
Okay.
So I'll graph it first to compare it, and it's the slope of it. Can you tell me the slope for that one? Remember, it's the coefficient on the x. Correct. So you go over 1, up 1, over 1, up 1, down 1, left 1, down 1, left 1. So that's the graph for that one. Nice arrow. And then what you'll do is this x minus 5. What's the slope on this problem? It's the coefficient on the x. So it's what?
-1?
It's the coefficient, the thing in the front. It's a positive because...
Oh, okay. I thought I saw the negative.
Well, that's the
Oh, it's
minus
the equal
5.
sign. Okay.
Okay. Oh my. I forgot. It's really, really small for you guys.
Yeah.
I'm so sorry. Let me see if I can make it a little bigger. Does that help at all?
Yeah.
Miss
Or did
Sparks
it go?
with the straight lines.
Huh?
Miss
Oh,
Sparks
you
with
like
the
my
straight
lines?
lines.
Yes, I do. I know they make you crazy, don't they, Natty Grace?
Ooh.
So the slope for both of them is 1. So what you would tell me when it says compare the graph, we're drawing the graph, but we're also writing that the slopes are the same. So you would say slopes are the same.
Okay.
Nice grammar there too. Please don't tell Miss White on me or Miss Manning. Anyway, and so then what you would do, what's the y-intercept for this? For the second?
5.
Yes,
Wait,
negative
for the
5.
second? Okay.
Negative 5. So, and if the slope is over 1, up 1, over 1, up 1, down 1, over 1, down 1, over 1, then it looks like this. Nice line again, right, Natty Grace?
Uh-huh.
So if the slopes are the same, the lines are what? They're parallel.
Mm-hmm.
So you would tell me the slopes are the same, so the lines are parallel. The y-intercepts are different. One is 0, 0, and negative 5. And then you would draw them. So this is the comparison via drawing, and then these are some of the description based on the equation. Slopes are the same, y-intercepts are different. One is 0, one is negative 5. Does that make sense, Tessa?
Yeah.
So you're just basically giving some information based on
Okay.
the equation. Now the second one, what is the slope on 26?
1/2 or
Yeah, so it's
0.5.
negative. Yeah,
Negative. Yeah.
1/2. So, but the y-intercepts are the same, right?
Nanny Grace said she has to go. And
Oh, okay. Bye, Natty Grace. Thanks for coming. So, but the y-intercepts are the same because both of these kind of have that understood plus 0 there.
Mm-hmm.
Okay?
Yeah.
So you would say B or y-intercepts are both equal to 0, but the slopes are different. So the lines are not parallel because one slope equals M and one slope equals negative half, 1/2.
Okay.
But on the one where the slope equals a negative 1, okay, this is the parent graph because you could just draw it again. And then this one, the y-intercept is the origin because it's at 0. So, but the slope, I've got to go one negative direction and one positive direction because it doesn't matter on the slope
Mm-hmm.
which one has the negative on it because a positive and a negative divided is going to be negative. So I'm going to go, if I go up 1, that's a positive direction. So I have to go left 2.
Okay.
If I go down 1, that's a negative direction. So I would have to go right 2 because that's positive. Once again, down 1, right 2. Up 1, right 2. So that's my line for the second one. So you can see that they're not parallel, that they actually intersect at the origin. So I've compared them graphically by drawing each of their graphs. And then I've written something about them because the slopes are different, but the y-intercepts were the same.
Okay. Will
But
something like that be on the test?
there isn't anything, I don't think there's anything like that on the test. The table is definitely on the test, and being able to evaluate a function at a given value is on the test. Was there any of that on here for y'all?
I'm not sure.
So that's why I was going over, Tessa, in the book. Number 29 and 30
In the book?
on page 214.
Okay.
Make sure you know how to do those.
What was the number? The numbers
29 and 30 on page 214.
Okay.
And let me go back to this, to yesterday's homework. Let me go there for just a second. Make sure that you know how to do 3 through 11 on page 203.
What were the numbers?
3 through 11. We
Okay.
did those in class yesterday. And numbers 14 through 21.
Miss Burks, I think your audio is cutting out.
It is? Can you hear me now?
I can now.
I wanted to make a distinguish, see where it says find the value for the directions for number 14 through 22. And it also corresponds to example 2 in your textbook. But where it says finding the x value, find the value of x so that the function has the given value. That's the ones where you're plugging in the answer to the f of x. And I really wish. So I want to make sure that y'all know the difference. Guess, don't be so mean to Finn. My dogs are fighting, sorry. I was trying to distinguish the difference between the two of them. So I'm just going to write down. I'm going to do number 14. F of x equals 6x plus 9 and then 3. Okay, so number 14 in the book. Are y'all there?
Yeah.
Okay. I thought y'all left me. Because that's the most important part, is to know when to be able to plug in, when you have to plug in a value into the x and when you have to plug in the answer. So let's look real quick I don't think it'll let me draw on here. It won't. Okay. The instructions for finding x values. Find the value of x so that the function has the given value. So what it's asking me to do on number 14 is this. 6x plus 9. And then I think the answer was 3. Is that right? Shh. So what it's asking me to do is find the x value if the answer is 3. So the answer goes over here because it says f of x. So what I'm going to do then is plug the answer in and then solve for x, which that's different than the other ones. So I would subtract 9 from both sides. That gives me -6 equals 6x. Then I'm going to divide both sides by 6. And the answer is -1. So you have to be able to distinguish the difference in the directions. Is that clear for everybody? Tessa, do you get that?
Tessa's on mute.
Oh, she is? Did I mute her?
Yeah.
I did?
No, I think she muted herself.
Oh, okay. Okay, Natty Grace left. Who else is with me still? Is that Jordan?
Jordan, this is Campbell. Jordan's still here, but she's on mute too.
She's on mute. Oh, okay.
Sorry.
Oh, no,
She's not.
Okay. No, that's fine. I just want to make sure.
My brother kept talking, so
I thought your brother was at school.
interrupted. He just left for school.
I'm just trying to make sure that that's the biggest difference between, I just want to make sure for the test tomorrow, the instructions for finding x values, there's 2 questions, like the ones 14 through 21, and then there's 2 questions like these. Three through 11. So notice what the differences are for the instructions. It says evaluate the function when x is -2, 0, or 3. So you have to be able to evaluate the function. And when the instructions say that, then you're going to put the value inside the x and solve for the f of x or the h of x or s of x or whatever the function is. And when the instructions say find the value of x so that the function has the given value, you're going to plug in the answer into the f of x or the h of x or the m of x and solve for x. So you're working it both ways. Does that make sense? Do you all feel about that, or is that confusing?
No, I think I got it.
Okay. Well, I think that I've been through almost, between the review and being able to do these problems from yesterday's homework, that's the most important things. If you've done the whole review and you did yesterday's classwork and those couple of extra problems that I talked about in math lab today, you all should be great on the test tomorrow.
Yay.
Tessa, do you have any more questions?
No, I don't. Thank
right.
you for helping me.
Oh, hey, no problem. And if you have any, like if you're going through some of the review problems and you have any more questions, let me know. Do you feel good about yesterday's classwork?
Yeah, I do.
Okay.
I do.
Do you, all the ones that I assigned, the answers are in the back of the book, right?
Uh-huh.
Okay.
Yeah, because they were odd.
Okay. Would you all like me to put the worked out solutions on Google Classroom?
Yes,
Sure.
please.
Okay. All right. Then
Okay, thank you.
yeah, I can definitely do that.
Okay.
The only thing is the worked out solutions that I'm going to post will probably have the evens in there too, which wouldn't hurt if you needed a couple of extra problems to do. But I left the DVD at school that allows me to kind of pick and choose the ones I post. So it'll be probably all the answers, 1 through, what did I assign yesterday? 1 through 35. It'll be all of them. So that'll give you a few extra that you could just look at to do, because this would be the only one where I would say y'all might want to take the extra time to practice. If you can do the worksheet, you should be good.
Okay.
Okay? Email
Thank
me.
you, Miss Sparks.
No problem. Email me if you have any other questions.
Sounds good.
Okay. Love you guys. See
Okay.
you tomorrow.
Love you.
you tomorrow.
Bye.
Bye.